So as part of your process documentation, you would also build a timeline of the whole case, and that is eventually like the key in the solving the whole case. So basic idea of building a timeline is that you have individual events that occurred over a different time period or like a different timeline. So you try to like, put all of those individual events on the timeline and try to correlate them, whether, like event A occurred before event B and so on. So here's an example of how a timeline can develop. So before going into that, we will look into some important factors that can, like, or the important piece of artifacts that you can look into in order to create a timeline. So user logon activity is a good thing to give you an idea of when an event happened, when the user logged in. This is, like it will give you a time for that. Network logs and connections, when a connection was established, at what time, by what process the connection was established. Similarly, file metadata can also give you information that you can use to create the timeline. And file metadata would include, like when a file was created, when it was last accessed, when it was last modified, and so on. Similarly, the internet activity, internet browsing history of a user can give you information to create a timeline. Lastly, like emails are also, because like if you look at the emails, they have the sent receive times and so on. So they can also give you important information to create a timeline. So here is an example of the timeline. So this example, like in this example, we are investigating a case where a child pornography file was found on a suspect machine. So you can see like your timeline begins just before the incident was reported. So say like at this particular time, the very first event that happened was like when the accused thought that he might get caught, he deleted the illegal file or the like child porn file in this particular case. Then the next event in this timeline is the incident report. So we'll list down at what time, what date this incident was reported. Next, we would like, depending on the type of investigation, we requested for a subpoena in order to get our hands on the suspect's hard drive, because like legally we cannot just like go and confiscate anybody's PC, or we cannot make copies. So we need to have like a subpoena or a warrant to do that. The next thing is like, after getting the subpoena, and another event is when you actually seize the system, and then you make the different copies of the system's like hard drive, like you acquire the data from the suspect's drive system or their laptop. Then the next step or the next event is the actual recovery. So you perform, after like acquiring the data, you performed some like examination, you did some examination, used like did some disk forensics and recovered the deleted files that the suspect deleted in the very first event. So after that, based on this evidence, you analyze this evidence, you find out that this is illegal, and then you report the law enforcement agencies that issued the arrest warrant, and this is how the case went. So just by like putting all of these events on a timeline can give you a better idea of the whole process, like from the very first moment the incident was reported to the last step when the case was closed or the arrest were made. Another important thing in process documentation is like the chain of custody. So as I mentioned earlier, when we were talking about the data acquisition, when you acquire the data from the suspect machine, like you make copies of it, store that data in your own hard drives. From that point onwards, you have to maintain a chain of custody. So every time, like one person shares that data to another person, they have to like, create a document like chain of custody document, where they will mention, at what time this data exchange, like person A handed over the files or the hard drives to person B at this particular time. And it will also have the description of like what hard drives were like exchanged or what data was exchanged. And it is very, very, very important that there shouldn't be any gaps between this chain of custody. So for example, like you're investigating a case and there is a gap of 10 days between this chain of custody. That would mean like for 10 days, nobody knew where those hard drives were. If that's the case, the opposing counsel can make the argument that, during that gap period where nobody knew who was the owner or in whose ownership the hard drives were, they might have like made some tampering with the evidence. So you want to make sure that you don't see this evidence tampering argument from the opposing counsel. So in order to do that, you have to make sure that there is no gap in the chain of custody. So these are some sample forms that like people use for to make sure to maintain the chain of custody. You might also have seen that in movies, when you see police officers moving the evidence boxes, they have documents like these pasted on top of them. So another discussion question for you guys, I will post them on Blackboard as well, is like, why is chain of custody important? And I expect you guys would like after the lecture and doing the readings, you will have a good idea why it is important and what can happen if there is a gap in chain of custody. All right. So now we will talk about like what are the different skill sets or different, say knowledge bases that you need to cover in order to be a successful digital forensic investigator. So the first thing is, what are we doing when we say we are doing a digital investigation? So the first thing is we try to make sure, we use the law in order to like assess whether some activity is legitimate or not. So for example, like if there is a file on a suspect's drive, we need to make sure whether it's a legal file or it's illegal. For example, child pornography is illegal. So if anybody is suspected of having that, that's against law. So the first thing you need to know is about the law. They can be different types of laws, like constitutional, like we have different amendments here, state laws are different. So all of that you should know before starting your case. Another example is like if it's like a criminal case, or if it's a civil case and you need to access the document, you need to access the suspect's machine, you would need to get the appropriate documents from the court, such as warrant or subpoena, in order to go to the suspect and acquire or seize their computer. The other thing is like, what do we seize? Like, what is the medium on which we do our analysis? And that is basically the hardware, like your laptops, your mobile phones, your tablets, email servers, you have personal computers, and so on. So you need to have hardware knowledge of these devices as well, like how these devices work and what are the individual components. For example, hard drive and a solid state drive, they are two different things. They store the data differently, so you need to know about their internal functionalities. The next thing is the software knowledge. So software knowledge, like there are different software components of these computing devices as well. So for example, operating system is one software component. You have file systems, you have applications, like all of these devices, they might be using different logging mechanism in order to log information. So you need to know all of that. And lastly, how we acquire this knowledge, or how we acquire, unearth or discover the evidences, we use different tools or digital forensic tools, and we need to know how they work. So their tools can be both hardware based or they can also be software. So in laws, like there are different types of laws. So the first, and like the primary is the constitution. So you have to do everything. When you are doing any process in the digital forensics, you have to make sure that it is legal and it is, it falls under the constitution. Then you have common laws, you have statutes, you have regulations, you have state laws as well. So here in US, like different states have their own laws. So depending the jurisdiction of your case, you have to refer to the state laws in order to make sure what you are doing is legal. Or if you find any evidence and you are you want to make sure whether it's a legal thing or it's an illegal thing that we found on the suspect's machine, you will have to refer to the local state laws. And hardware knowledge, like it's basically about the computer hardware, what type of hard disk is there, whether it's like solid state drive or the other hard drive, if it's a USB, or like any flash drive or any memory card. So we need to know the mechanisms or internals of those devices as well, like how they are storing the device, how they are storing the data. In software realm, we have, the first and most important thing is the operating system. So there are different type of operating system running on these different devices. We have Windows, we have Linux, iOS, Android, and so on. And in Linux and in Android, you have like, multiple different versions of these operating systems as well. So in order to do like, evaluation or analysis of any like forensic artifact, we need to make sure that we have the knowledge of the operating system that machine was using. The next thing is the file system. So file system, similar to the operating system, is another software component. So all these different operating systems, they have their own file systems as well. For example, Windows mainly use NTFS or FAT. In Linux and iOS, we have the HFS, HFS plus, APFS, like for the iOS. So all these different file systems, they store and save and retrieve and delete files differently. So, like all of these file systems, they have their own mechanism in order to managing the data on your hard drive, like, how the system will store the data, like, or store a file, how that file will be recovered for the user to view that, what will happen when a file is deleted by the user, and so on. So that like all these things, they are governed by the file system. So we need to know like the working of these different file systems as well. The next thing is the file structure. So, like image files, office files, text files, they have different extensions, they have different encodings, and so on. So we need to have some idea of these things as well, like what are the different file extensions, how we can, like use them for our investigation purposes. So most of like actually all of this, like things that are covered in this slide, for example, operating system, file systems, and file structures, we will cover in different lectures throughout this course. So the next thing is the tools. So tools can be both software tools and hardware tools. So let's first talk about the software tools. So these are the tools that you will be using in order to, like acquire the data, capture the data. For example, FTK Imager is a popular tool that you guys also will be using in one of your labs. And that is basically used to, like acquire the image, like the RAM image, or take a snapshot of your of the machine or of your computer. Similarly, Topsy is a very popular digital forensic tool, which is generally, like used to recover the data from the hard drive. So you can like, recover deleted files. You can also look into emails, phone directories, and so on. On the hardware side, there are also specific hardware tools that are used in digital forensics. One example is the write blocker. So whenever you are like, reading something from the suspect's hard drive, you have to make sure that it is a one-way process. That means like the reading process that you are performing on the suspect's hard drive, it is not writing anything, or it is not altering the state of the suspect's hard drive. So, like if we don't use write blockers, like there is a chance that the suspect's hard drive might be updated, or like, there might be some like minor changes in the suspect's hard drive. So in order to avoid all those things, forensic investigators use dedicated hardware tools such as the write blockers, which make sure that this reading operation doesn't contaminate or doesn't alter the state of the suspect's hard drive. So in this course, our main focus would be on computer forensics. We will talk about the disk forensics. We will also have like a couple of lectures on memory forensics. We will use different tools. The main operating systems that you will be working in is Windows and Linux, because most of the tools such as Autopsy and FTK Imager, they are window-based. And in Linux, we will be using volatility and strings for our memory analysis. So I know like there was a lot of information in this slide set, or in this week's reading, starting from law to, like what are the different type of investigations, what are the tools I need, the documentation I need, and so on. It can be overwhelming, and you have to understand that, this is not like all done by one person. So if you look at the different companies that perform digital investigation, they have a complete team of both the technical people that have the technical knowledge, on the computer side, and they also have the legal people that have the legal knowledge. So most of the time, like obtaining subpoenas, warrants, those type of things, they are handled by the legal team and the technical team, which will be most of you guys. Their focus is just on the technical side of like, making collecting the data, doing analysis on like examining the data, doing analysis and reporting. The next thing is how this whole digital forensics, knowledge or like domain fits into the cybersecurity, overall cybersecurity domain. So computer forensics is part of incident response. So incident response is like, whenever any asset, like whenever any company asset or whenever any computer is targeted, there's a whole process that we will discuss in the next slide, which is called incident response. So it starts from identifying the problem, to problem containment, where you can find the problem, then you try to eradicate the issue, whether it was like a malware or a virus or like a backdoor, you try to get rid of it. And then like once everything is done, you report everything, like, it's kind of like lesson learned. What did you learn throughout this whole process? And you want to make sure that those mistakes are not, repeated. For example, if any of the attack exploited any vulnerability, after like, making sure that the attack is eradicated and the recovery is done, you try to make sure that you patch all the vulnerabilities that were out there as well. And incident response is integral part of information assurance, so your overall cybersecurity umbrella. So this is how the incident response methodology looks like. So the first thing is whenever, like, for example, you are in the cybersecurity team of a company and your company is under attack, like one of the PCs is like, corrupted or it is like attacked by the attacker. So the first thing is like, to analyze what happened, you will like get some report from maybe the user that were using that computer, that, hey, my computer is working abnormally or something like that. So the first step is preparation. So depending on the nature, like, your interaction with the user, like they can tell you what is happening on their PC. You will make your prepare like the whole process plan, and you will like prepare like what tools you need, what, like things you should be looking at, and so on. The next step is the identification. So once you have like all the tools that you need, the next step would be examining the targeted PC and trying to identify the virus or the malware or the backdoor channel and so on. So once you find like the infection, the next step would be containment. So at this stage, you want to make sure that the infected device, it is not connected with your, say, company's network anymore, and the virus or say the malware cannot spread from one machine to another. After containing or after isolating the like uh, malformed device, the next step is eradication. So you have isolated the virus or the affected device. Now you want to make sure that you identify the virus or the malware within that device and delete it. So that is the eradication step. And then after the eradication, you have the recovery. Once like, your laptop is clean or the machine is clean and it is okay to use again, you integrate it back to your company's infrastructure. And lastly, you report everything, like from the first step to the last one, like what were the vulnerabilities that were exploited, how the how the vulnerabilities were exploited. For example, what type of malware or virus was there? Was it a back channel and so on? And then the next thing would be, what did you do? Like, how did you eradicate them? How did you patch those vulnerabilities and everything? And why do we need that? Because the next time this type of attack happens, we would know from our past experience how to handle it. So all of that is like, this is the complete cycle of incident response. And as you can see, like most of these steps, they also confine in, or they also overlap with the digital forensics as well. So in digital forensics, what are the career paths? So, like since most of you will be graduating soon, you can look into LinkedIn and you can find, jobs like cyber forensic analyst or digital forensic examiner, on incident response analyst, and so on. So with the knowledge, like that you will learn as a digital forensic investigator, you can like apply for all of these different type of jobs. And the job, like, they are not confined just to forensics, because since we will be learning about the internals of the different file systems, the operating systems, the hardware, and so on. That knowledge can also be applied in different fields such as the penetration testing. We will be doing the live memory analysis in this course. We'll be using volatility tools and so on, and that can be like used to do the malware studies as well. So jobs like when malware analyst, they can also open up, or you can use this knowledge in those type of jobs as well. So lastly, let's talk about different challenges that are there in the digital forensic domain. So the first challenge is like, it is a relatively new field as compared to the other fields. So for example, like you have the whole thing started in the early, like late 80s or 90s. So that is when, like the whole digital forensic domain started. And still there are a lot of things for which we don't have tools. So people are, like continuously working. For example, for the memory forensics, volatility, people are developing the volatility plugins or scripts continuously that can be used for future cases. And the other thing is like, unlike other sciences, for example, like physics, chemistry, math, where you have like theoretical knowledge and then you can perform some experiments based on that theoretical knowledge and verify whether, your experiment results were right or not. So in this case, in digital forensics, we don't have, like that much theoretical background available. It's more like detective work. So we are trying to find the different type of evidences from the suspect's machine and trying to relate them, like make a story, make an argument out of all those individual pieces of evidence in order to like help the law enforcement agencies. So there are legal challenges as well. For example, the first thing is the evidence admissibility. So as we mentioned earlier, or actually throughout this slide set, that in order to confiscate the suspect's PC, you need to get a subpoena or a warrant. So what will happen if you don't get the proper legal documentation and you just like acquire the suspect's data one way or another? So if you acquire the data without following the proper legal channel, that data will not be admissible in the court. So for example, like even if you found the evidence of a very serious crime on a PC and you didn't follow, you didn't get the subpoena or you didn't get the warrant in order to search that PC, that piece of evidence will be inadmissible in the court. So you want to make sure that, like whatever you do, whenever you make the data acquisition, they are done legally. The other thing is, like these court cases, and also like getting the subpoenas and warrants, it can take time. So there could be days from when, like you file for the warrant and you actually receive the warrant. And during that time, the suspect can make changes to the devices. For example, if somebody is, like if they think they are being targeted or they will be captured, they might delete or format the data or the sensitive data that is on their devices while you are getting the documents or while you are getting the subpoena. So because of these delays, like there is a chance that some data can be, or some like pieces of evidence can be distorted or can be damaged. The last thing is the technical challenges. So, like as we mentioned earlier, there are different type of operating systems out there in different type of devices. You have Windows, you have Linux, you have iOS, you have Android, and maybe, like in the next 10 years, there'll be a new system as well. So like all these different operating systems and different file systems, they like, this heterogeneity of these systems, they present a big challenge for the digital forensic community, because like for the same thing you will have to create tools that can work in these different operating systems. So that's why like earlier I mentioned, like most of the tools like FTK Imager and Autopsy, they mainly work in like they are window based. So like it is a challenge to make them work for other systems as well. The other thing is the incredibly large storage capacity. So if we go, like not five, say like 10, 20 years in the past, the hard drives, they were not like that large. They were limited size, maybe, like 500 GB at max or 256 GB or 100 GB and so on. But now, like, with even with the cloud computing and so on, you have hundreds of GBs and TBs of like hard drive or storage capacity that is available to any person. And like that also makes the life of the digital forensic investigator difficult as well. So for example, if you are investigating a case where you have to like capture or acquire the data from accused, which is in hundreds of TBs, you need to make sure that you have like those hundreds of TBs of storage available where you are supposed to put their data. And on top of that, we, as we discussed, like we always make multiple copies of it. So just imagine like how much storage you would need if you are like investigating a case that contains large amount of data. The next thing is like the networking environment and cloud environment also exerts a great like difficulty in forensic investigation. So why is the challenge? Because like if it is just one device, like if you just get if you are investigating a crime, you got the warrant, you went there and you acquired all the data that was there on the suspect machine. But what if the suspect was doing all the illegal activity using a cloud computing service, or using like say remote login to another device and so on? So in that case, now you will have to go through the legal channel again, like require like get the warrants or subpoenas for those remote services, and then try to get data from them as well. So all of these things, they have like some technical challenges that the digital investigation community has to overcome. And the next challenge, which divides the digital investigation from the physical investigation, is the location of the crime. So if you look into the physical like crimes, they occur in the physical domain. So like you will have one crime scene generally, like you see in the movies, the police cordon that area off, and it is like nobody can go there, and it is just one place where you can find all the evidences about the occurrence of a crime. Whereas in digital forensics, you have two different, locations. One is the victim system. This is where, like, this is the system that the victim was using. It will have its own RAM. It will has its own hard drive. There will be a different set of processes running on the system and so on. And the other will be the perpetrator or the attacker system. And the challenge here is, like this, the victim and perpetrator or the attacker, unlike the physical domain, you can say incidents or crimes, they can be far away from each other. So you can say, like if the victim is in the United States and the attacker is somewhere in China, or say, like some other part of some other like Eastern country, there is a huge gap, the physical gap between the two like devices. They are on different continents, they are on different countries, they have their own legal systems. So in order to get the data from like both these devices, it is a big challenge. And most of the time, say 99% of the time, you are not even sure who the attacker is. So there is no guarantee that you will be able to get any data from the attacker side. So all you have is the victim system and the victim's machine, and you try to like you try your best in order to acquire everything that's out there on the victim machine, and depending on that, try to trace back to the attacker and see like what you can recover from there. So that's all for this week's lecture. I have my office hours today from 2 to 3. If you have like any questions about the this week's like readings, or if you have any question about the lecture, please feel free to reach out to me during my office hours. You can also like email me any questions if you have them, and also like you can use the messaging on the Blackboard as well if you have any questions.